This video is for the MCA class, Math for College Algebra, not geometry. And it is sort of a quick review, since we're not going to have time to do that in class, after the first quiz, which was on rational numbers, irrational numbers, combining fractions, sort of, but combining fractions when you had variables was what made it tricky. Kind of, I think you call that rationalizing a number, a denominator, or a numerator also, if you're trying to look it up. Let's see. We also evaluated a absolute value function when it had variables in it, which I'm actually not going over some of those things. You need to go back and watch the other video for those. Mainly in this video, I'm going to go over exponents and radicals. We did not do very well on that. Actually, we didn't do very well at all on any of it, just FYI. So happen to watch this before class. Things will be changing. So anyway, I'm going to go into exponents and I'll give you a quick review of the concept, then work a problem out. I'm not doing the problems from the quiz, so don't think this is exactly what you're going to need to know how to do. You're still going to have to apply the concepts. But if you watch this video, you should, I think, improve for sure on at least the exponents and radicals part of it. So quickly, I said the main concept or the main rule you needed when you dealt with exponents was the product rule. So I'm only going to go over that. Well, I'll probably talk about some other rules. If we have the same base, so 5 third times 3 to the 4th times 5 times 3 to the 2nd. We said we can combine. Now, a lot of you said we can multiply the bases together or combine the bases or something like that. We don't do anything with the bases. We can combine the exponents for the terms that have the same base. So for the ones that, for the 5s, basically, I can combine those exponents. Well, don't forget there's a 1 there. So I say 3 plus 1, and I get 5 to the 4th. And that is time. So I don't do anything with the 5 and the 3. I combine the 4 and the 2 on those now. And I get times 3 to the 6th. So that's all I can do. And most of you actually got the one right that was on the quiz like that. So moving into one that was a radical problem, we said if we have a radical, then we have, let's see what would be a good one. I don't know, we'll just do 60. 60 will probably work. If I want to, so again, simplifying means there's a better way to write that using math notation. We don't want to leave it like that. We want to create smaller numbers, basically, kind of like simplifying a fraction, that are still that same number. Preferably, we'd like to pull a number out from underneath the radical, because we don't like to have numbers under radicals if we can help it. So if there's a perfect square we can think of that is a factor of 60, then we want to kind of break that out into a perfect square times a number that's not a perfect square. The perfect square will be able to pull that square root out, and then the other number will have to stay under the radical. You don't know what I'm doing here when I do this. So now I got to see, yeah. So there is a perfect square that will work. So 4 times 15. So 4 is a perfect square. That means I can take the square root of 4 and it's an integer. That's all perfect square means. So I can't really do anything with the 15. There's 3 times 5. Neither of those is a perfect square. So there's not much I'm going to be able to do with that. But with this 4, and remember, if there's not a number there, there's a 2. So just as a reminder, that comes into play, I think, on the quiz. If I want to take the square root of 4, that's just 2. Oh, and I also showed you in class, that's the same thing as square root of 4 times square root of 15. So that, I think if you remember that, it's helpful, because now you can clearly see, oh, well, that's 2. Square root of 4 is 2. I still need to say times square root of 15. That doesn't go away. Well, the way we write that is just by removing the multiplication symbol. That's the final answer. So you have to find a factor that is a perfect square. Now, I guess I'll do one of these two. If it's not a square root problem, so let's say we have a problem that is, I don't know, 40. But it's a cubed root. It's the same concept, only we need to look for perfect cubed roots. So perfect cubed roots would be 8, then 27, then 64, 125. Normally, you're not going to go a lot higher than that. But so the reason 8 is a perfect cubed root is because 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. 4 times 4 times 4. And then I think hopefully you understand. Those are perfect cube roots. So I need to think what perfect cube root, again, because I have that, it needs to be cube root. What perfect cube root should be a factor of 40? Well, 27 is not going to work. 64 is way too big. So 8 would really be my only option. And as I'm sure you know, it does work. So again, we're still doing this. I'll do the somewhat long version of it. So that would be, ooh, I don't know what just happened there. And again, so the, oh boy, I love when this really makes me happy when it does that. There we go. Right, slower maybe. So the cubed root of 8 times the cubed root of 5. So I'm just, again, simplifying means breaking it into the correct math notation, basically. So I can now take the cubed root of 8, that's 2. I'm still multiplying it by the cubed root of 5. Well, the way we write that is just 2 cubed root of 5. We just remove the multiplication symbol. So that covers two of the main concepts. I think there were several problems on there for those. Now, when we get into something that has variables underneath it. So we said, what if you have like the 5th root and you have x to the 3rd? I'm going to put a number in there in a second, but I did not mean to write that. X to the 8th, and then we have y to the 6th, and then hold that thought. Oh, just really quickly, the exponents, if you don't have parentheses, I'm going to go over this again later, but I'm going to mention it here too. The exponents are only on the base. Oh. The exponents are only on the base that is attached to the exponent if there are no parentheses. So for example, if I have x, y to the 6th, only y is being raised to the 6th power, not the x. There were a bunch of mistakes where people were trying to raise both of these to the 6th power. That is totally incorrect. And that was missed by a lot of people. So that is y to the 6th times x. We could rewrite it. X times y to the 6th. The only time we're applying that exponent to both terms is if there's parentheses around it. And we went over this in class. That means we are taking the base, xy is the base, times itself 6 times. So you have to get those two straight, or else it's going to be tough to do well on that exponents and radicals part of the quiz. So I'm going to go backwards for a little while. Oh, man. Oh, I had the wrong button. Oh, there we go. All right, so now there's multiple ways to explain this. I'm going to go with what I think is the easiest version. Too large there. So we said that I didn't put a number in there. So let's say, it's a pretty tough one to do. I don't know. I'll say 64. So what we would want to do is say, okay, well, first of all, what can I do with that 64? There's no fifth root of 64. Is there another number I can change it to that might have a fifth root? Well, I'll just tell you right now, if it's a number, if it's a root is that high, you're gonna have to have like a 2 or a 3. There's any number higher than those is gonna be way too big a number, unless you have a number that's here that's like in the hundreds or in the thousands. But I would just need to say, okay, well, let's see what 2 times 2. So 2 times 2 times 2 times 2 times 2. So if we have at least 5 2's, we're going to be able to do something with it because we're taking the fifth root. So 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So I need one more. So that I can change to 2 to the 6th power. So first of all, that's what we need to do is take the number part and make it a base and an exponent. So I'll break it out, and I'm going to go ahead and do two things at once. 2 to the 6th times x to the 8th times y to the 6th. And all of these are the fifth root. So now we said, again, there's another way to think of it. I'm going with the converting a root or a radical into an exponent, a base and an exponent. This is like 2 to the 6/5. We take the exponent underneath the radical and put it over the root times x to the 8/5 times y to the 6/5. I think this is much easier. Some of you did this, but you forgot either the last step or the last couple of steps. I can now make this into, how am I going to show this? Basically, if we have 2 to the 5/5, that equals 2. It's 2 to the first power. So what we sort of have now, this is going to be a little, I don't think I explained it this way in class, but I'm going to go ahead and do it here. Maybe that's why we didn't get it right, because I didn't explain it this way in class. So I now can break this in, and this is using the product rule. So 2 to the 1/5 times 2 to the 5/5. Right? Because again, I would just be adding the exponents, and that would give me 6/5. So I'm basically trying to pull out a perfect square, sort of. 2 to the 5/5 is sort of a perfect square. I can pull that 2 out now and make it just the integer 2. So now I'm going to do the same thing with all the others. X to the 5/5. That's a 5, but I'll change it. And then times x to the 3/5. Again, all I'm doing is taking that 8/5 and trying to pull out something that's going to be the number 1. Because if I can get an exponent of 1, that means I can take that out from underneath the radical that we started with. Let's see. And then last, I would do the same thing with y times. So again, I can only do this if the numerator is bigger than the denominator, because otherwise I wouldn't be able to pull out a full 1 from the fraction. So like if this 6, if I had y to the 3/4, well, I can't pull out a full 4/4 from that. The numerator is not high enough. You don't understand all of that. I'm going to give you a super shortcut at the end of this. And then times y to the 1/5 also. Right? Again, if I take the y's, I add the exponents, I get 6/5. So now what each one of these means, I'm going to kind of do 2 steps at once. That's the fifth root of 2. This is just 2. I kind of did it out of order, but that's fine. X to the 5/5 is x. X to the 3. I did that wrong. Nobody. If you thought that, this is supposed to be a 5. So go back. That has to be a 5. The denominators all have to be 5s. So that is now the 5th root of x cubed. So I'm kind of doing the opposite. I'm taking the top number and it becomes the exponent under the radical, and then the bottom number is still the root, just like we've been doing. So that 5 will come down there and be the root right there. Oh, didn't mean to do that. All right, so now 5 is still here. And then last, I do the same thing with the y's. So the first y is just y. The second y is the 5th root of y. Been kind of doing 2 steps at once. So now all of the numbers that were, that are now integers, basically, I can pull them out and put them in front. I need a radical. Remember, if we have numbers underneath a radical, assuming they're the same root, which these are 5, 5, and 5, as long as you have the same root, you can do what I'm about to do. What? My finger's just too fat. There we go. So now I have the 5th root. I can just multiply those 3 things together. 2x cubed y. So this is my final answer. 2xy times the 5th root of 2x cubed y. Now, I'm going to go back to the actually, write the original. That's the original problem. Let's see how I can do this. There we go. So I'm going to put this right next to the final answer. And I think a lot of you will just be able to skip to the final answer on this type of problem instead of going through all of that. Okay. There we go. So ultimately, here's what we do. For the variables, it's actually pretty easy. If you have, so if I have the 5th root, for example, if I have an exponent higher than that root for a variable, then I can pull out that variable and bring it out as an exponent. So I just basically am saying 8 subtract 5, and that leaves me with 3 underneath because I need to pull 5 x's out, because that's what the 5th root means, is x times itself 5 times. And then for the y values, well, this was bigger than 5, so I basically am saying 6 subtract 5, and that left me with 1 that has to stay under the root. If these exponents down here would have been even bigger, even larger, so let's say the x exponent would have been 12. Well, I could have pulled x squared out because it would have been x to the 10 underneath the radical. And then I'm basically able to pull 5 x's out twice because there were 12 of them. Here, I'm going to just show you that visually. I'm only going to do it with 1. So the 5th root. Here, I'll do the 6th root of x to the 13th. Well, I can pull 6 x's out, but I can actually, so that would be x, but I can pull 6 x's out again. So 6 x's from the 13 gives me x as an integer, but then I can pull 6 more out, so it gives me x again, and then that's times underneath, I would still have an x left. The other way to do it, so again, that gives me x squared, because if I pull 2 of them out, times the 6th root of x. The other way to do it, and again, I think this is easier, but is just say, okay, well, I know I can put this 13 over that 6. So x to the 13 over 6. Well, if I do the math on that, that gives me x to the 12 over 6. which I can make into an integer basically. And I would still have x to the 1 over 6. It's a 1 up there, by the way. So now if I simplify that, I have x squared times the 6th root. So now I'm just converting it back into a radical. You have to do this part right here. You can't leave it as an exponent because in the problem I said I want a radical expression. You left it as an exponent, you got it wrong. I gave you some partial credit for understanding that concept, but you didn't get full credit. And then, so my final answer is I don't need the multiplication symbol. That would be the answer. The 6th root of x times x squared. Oh, that was longer than I wanted to spend on that, but that's fine. All right, so that covered a few of them actually. A lot of people struggled with a problem that had variables, exponents, negative exponents. It was a division problem. And we'll do that one. I think we're on to that one. So for example, I have 3x to the 5th, y to the negative 2 squared divided by 3x squared y or something like that. So there's several ways to do it. If you really remember the rules, you can do something with this 2 on the outside immediately. I kind of taught you one concept. And that one concept was, let me write smaller. That one concept was, what does an exponent mean? And then how do we use the product rule? We didn't really focus on learning all the rules. Well, this exponent of 2 right here means I'm taking that base and multiplying it times itself. Oh, and I'm going to go ahead and do this. I didn't see really anybody doing this, but I think it would be helpful. First of all, this is what is in parentheses. Remember, we're multiplying individual terms. None of those are paired together as one number. Those are all individual numbers. Because a lot of people are forgetting to apply the exponent to a term inside the parentheses. And some people are trying to apply an exponent to a number when they shouldn't be. But remember, they're individual numbers. And that's, oh, shoot, sorry. I'm taking care of the squared now too. So that's times, and then again, same thing, 3 times x to the 5th times y to the negative 2. And then all of that would be over 3x squared y. Right over there. All right, so now we can really just get rid of the parentheses. So just imagine, because this is, remember, this is just a multiplication. This just means we're multiplying. Actually, I'm going to do that. So the parentheses are just telling us we're multiplying. So now we're to the product rule. If you have same base, we can add the exponents. If we have same base here, we can add the exponents. And if we have the same base here, we can add the exponents. Now, we can also do something else. So depending on how you want to handle that, it's up to you. Oh, wait, I'm not going to add the exponents. Scratch that. We can do that. Then you would have to know the rules, though. So I'm going to break this out, and oh boy, it's going to be tough. I'm going to have to zoom way back in. All right, so I'm going to this on the screen. Yeah, it's going to be a little tight, but that's fine. Ah. All right, so I'm going to say this is really equal to 3 times 1, 2, 3, 4, 5 x's there. I'm going to say y to the -1 and then y to the -1 there. That's a little tricky. The negative exponents can definitely be tricky. So I'm going to show you a trick for those. And then this is the same thing, 3 times, just remember there's multiplication symbols in between all of these. Y to the -1, y to the -1. All right. So now, make sure I have that right. Yeah, 2 net y to the -1. If I added all those exponents up together, I would get, y to the -4, x to the 10, 3 to the second. But again, I didn't want you to memorize rules, so I showed you this way to do problems. 3x times x times y. Now the x's are pretty easy in the 3's. That 3 can cancel out with one of those 3's, take away 2 x's. So now up top, we're down to 8 x's. So on my top part of my answer, I'm going to have x to the 8. I'm going to have 1 3 still left. So we got to figure out how do we handle those y's. Well, I'm just going to tell you the shortcut. Anytime, and I think I told you this in class, but I'm going to tell you again. Anytime you break it out like this, once you get to this stage and you have a negative exponent, even if the negative exponent's on the bottom, so let's say the y on the bottom had a negative exponent, this would still apply. You're going to move all of those numbers or variables or whatever has a negative exponent, you're going to move it to the other side of that fraction line, the division line. So really what this becomes, and I'm going to start simplifying, 3 times x to the 8 over, I don't do anything with the y down on the bottom, because the y down on the bottom has a positive exponent, so it doesn't go anywhere. But all those y's up top come down here. So I had one of them already that was positive. So the first one, I'll color coordinate. That y right here is that y. All of these other y's with the negative exponent, and I don't have the negative exponent anymore when I move them, so don't keep it. That's what a negative exponent, or that's how we take away a negative exponent. We said put it under the number 1, make a fraction and put it under 1. So I move all 4 of those to the bottom. So my final answer then would be 3x to the 8th over y to the 5th. So your shortcut, assuming you know how to use the product rule and break things out and then cancel terms out, your shortcut is once you get to this stage, when you have a negative exponent, whether it's above or below the fraction line, it doesn't matter, you're going to move it to the other side of the fraction line. So they were on top, so I moved them to the bottom, and I took away the negative. There's no longer a negative on it once I do that. Hopefully, if you don't understand that, you can go to D2, or you can come. I have but that's not really for you guys on Thursday. You can get with me, and we'll see if we can figure it out. Let's see. There were a couple pretty well, I say tricky. I mean, really, I'm not going to go over the one where you need to combine like terms. That was the last thing we did, I think the last lesson before the quiz. So you're going to need to go back and watch the last lesson before the quiz. It was on radicals, and it was at the end. I'm not going to go back over that one. I will go over these two, though. So if we get that, first of all, so here's where I kind of brought up part of this. If you have 9y to the 4th times 2y to the 0, and then that to the 3rd, I am going to encourage you to break this all out. If you really know your rules and if you're really good, which I don't think many people can say that based on the grades so far, and I'm almost done. I think it helps you to just say, well, that's 9. Remember, the 4 is only on the y, so you can even write a 1 in there. So you remember, times Now I'm going to actually take baby steps, and I'm going to say it means 2y to the 0 times, because I'm doing it 3 times, 2y to the 0, it's a 0, times 2y to the 0. So that's my first baby step. You don't have to show all of this. So I took the base, and I multiplied it times itself 3 times. Now I'm even going to break that out again, just to make sure that we're getting it. So now this, I really don't need the parentheses, is 2 times y to the 0 times 2 times y to the 0 times 2. Nobody did this, by the way, on the quiz. And pretty much everybody missed this problem. I think everybody did miss it. Y to the 0. Now I can figure out what's going on mathematically. And then eventually I'll need to combine it all back into one term. Combine is not really the right word. We're just going to be taking out the, well, we're combining exponents, I guess. So that part is right. So first of all, before I even worry about bases, I have 9 to the first times y to the fourth times 2. And here's where people messed up when they didn't do it this way. Times 1. That is not y to the 1. That is not, we don't still have the y left. A lot of you left that variable in there when it was to the 0. Oh, the key here, by the way, this 2 is not being raised to the 0 power. That 2. A lot of you changed the 2 to a 1. Like you changed everything in the parentheses to 1. The exponent is only on the y. Only goes with that. Now, if the 0 would have been out here, then yeah, everything in parentheses would have just gone to 1. So 2, I'll show you the difference. I'll do it in red. 2y to the third even, we'll flip them. And then all of that raised to 0, that does equal 1. Everything just goes to 1. Because basically I'm going to have 2 to this, because if I use the rule, 2 to the 0, and then y to the 0 would be 1 times 1, which would be 1. Because there's a 1 on that. But again, the 0 in the red now applies to everything in parentheses, so that just gives me 1. This 0 over here only applies to the y. So got to keep those straight on that problem. On the problem, you'll have to redo. I'll have to do some. Let's see. One more. Oh, 2 more. There we go. All right. So anyway, if you break it out, you don't run into that problem, hopefully. So let's see. Times 2 times 1. What in the world was that? I don't know what is that. This is, I always thought it was my smartboard. Maybe it's not my smartboard. Maybe it's my smart app, smart notebook app. Blue. So now I have the next 2, and then again, times 1. All of the y to the 0s go to 1. Break it out. I think it makes it a lot clearer, hopefully. Now I just multiply everything back together. If they're numbers, I can multiply them. I only am going to be left with y to the fourth. All my variables went to 1. So now I just say 9 times 2. Actually, I can do it a different way. 2 times 2 times 2, I know is 8. So I'm just going to do 9 times 8. So 9 times 8 would be 70. So that would be the final answer. So I'd encourage you to break it out like I did. If you really know your rules, there's a shorter version of it. You can just multiply the exponent times the exponent outside the parentheses times the exponents inside the parentheses. But most people that tried that didn't get it right. So breaking it out's a lot safer. Might take you a little while longer, but a lot safer. Let's see how am I gonna do that one. I'll just this one up. It's similar. So let's say we have 5 to the m. Actually, we'll say 5 to the 4m for that one. Times 5 to the negative 2m divided by 5 times 5 to the just m. Now there's a couple of different things you can do, especially now that I've told you if you see a negative exponent, it just moves it to the other side of the fraction line. I could actually take that 5 to the negative 2m, move it to the bottom. I'm not going to do that. Since it's the product rule, I'm not going to break it all out into a long string of 5s to the m, because you should understand, hopefully, the product rule. I might do it in a minute. I'm not going to do it right now. So anyway, if I have the product rule, I can just add the exponents. This is why I didn't move the negative 2m to the bottom, because I knew the negative was going to go away. So I can add those exponents because I have the same base. And I would get 5 to the 2m divided by 5 times 5 to the m. Now, one thing I'll mention now, I can't multiply 5s together in this case because I have an exponent and I don't know how many 5s I've got. Like that m, I can't just randomly multiply 5 and a 5 and get 25 because I don't know how many m's or how many 5s would be left over. I don't know what m is. Like, boy, it's hard to explain that, even to show you, really. If you don't have the same exponents, you could still add the exponents. I do have the same base, so I could add the exponents, but you got to remember that's a 1, not an m. Because there's not really much I could do. I could make it 5 to the 1 plus m power, which I would have accepted. Nobody did that. I would have accepted that. But just remember, if you don't have the same exponents, then you can't multiply the two 5s together, or whatever numbers it would be. It's going to kind of go away anyway, so it doesn't really matter. Now I am going to break it out. So I have 5 to the 2m I could think of as 5m times 5m, because that would be 5 to the 2m, right? You don't really need to do this if you remember the rule that I'm about to do in a second. Then down here I have 5 times 5 to the m. Well, I can do the canceling. If I have same base and same exponent, then it's the same exact number. That's why I can do that. Same exact number. Whatever m is, it's going to be the same number on top as it is on the bottom. So those two numbers are going to cancel out. Now I cannot cancel out the 5s or anything. Again, I'm going to try to explain this. I don't know how many 5s are on top. Like if I had, let's say m is 3. Well, if I have that, then my answer would just be, oh boy, how do I explain this? Very difficult to explain this. It would wind up leaving me with 2 5s. Yeah, there's just no way to cancel. If you don't have the same, just remember this. If you don't have the same exponents, you can combine them. So the product rule still applies, the quotient rule still applies, but the only thing you can do with the exponents is do this and say m subtract 1, because there's a 1 down there, right? So using the quotient rule, I could do that. That's accurate. I kept the same base. I took the top exponent and I subtracted the bottom exponent. But I don't know what m is to try to combine it and make it like anything, like just one exponent. I can't do that. I don't, boy, that is a tough one to explain, trying to use actual numbers. So anyway, that may just be one that you have to memorize. That's the same reason why I couldn't combine them when I used the product rule. When I had on the bottom where I had this 5 times 5 to the m, I couldn't combine those into anything because it would have just been 5 to the 1 plus m. I don't know what 5, or I don't know what m is to try to combine them. So anyway, that's was one of the trickier problems for sure. You're gonna be you still have a variable left in the exponent. I would have been fine with this as the answer if you didn't combine it down into this. I would have been 5 with 5, are fine with 5m over 5. Either one of those is acceptable. And I believe that's all I was going to go over. So that's not everything on the quiz. It's not, I didn't do hardly anything with some of the expressions where you had two fractions and you had variables in the fractions and you had to try to combine them into one fraction. You need to watch the videos. I even specifically told you that I loved 2 problems, maybe even 3 problems. So they were all on there. And they weren't that much different. So, but only a handful of people got those right. A very small handful, especially if you are like thinking about how many people got both of them right. That was a really small number of people. I told you I loved those in class, but nobody went back and looked at them apparently. So I'd go back and look at them. I'm not doing those in this video.